Bluetooth controlled robotic arm that I've written. And okay, so in the beginning, we are obviously using the Bluetooth module HC05 and the servo motors. So we have to include those two header files. Afterwards, we're going to store these values as functions, servo 1, S1, S2, S3, and then SG. So then these three are for the X, Y, and Z axes of the robotic arm. So those are the three servos that are controlling the motion. And then we have a fourth servo motor for the gripper. So I denote by SG. Then afterwards, we are going to connect the Bluetooth module, RXTX, so those are just the pins, yeah? And then now, before the actual void, the setup function, we're going to write another function, which is just, it's user-defined, but it's a void zero set, basically. And what I want to do here is to initialize the servos to the 0th position, so that they kind of start off neutral, in a sense, you could say. So the bottom two servos have to be oriented 90 degrees. And then the third one, this is the one at the top, is going to be at 40. And then we put the last one, the gripper, at 0. And then we have a delay of 1 second, basically. After that, in the void setup, we're going to attach each of the 4 servo motors to the digital pins of the Arduino board. So it's just the digital pins 9, 10, 11, and then 6, which I've connected. And then after that, I call the 0 set function, which, as you have seen, is already been defined here, and then with another delay. And then after that, we start the Bluetooth. As you can see here, serial.begin with the baud rate. And yeah, the Bluetooth has started. After that, we have a void, the main loop, basically the main software. Here, we have if Bluetooth available, which is equal to 2. So first, what we're doing here, the main point of this first part, is to kind of detach all the servos. Now, this is because when they're all connected, all the power goes equally to all 4 servos. But in the robotic arm, we are not always using all 4 servos, well, all 4 of the controls at the same time. So that's just basically a massive waste of power. So here we want to detach everything so that basically nothing is connected, in a sense, until we reattach it. Now, this is going to redirect the current to specific servos while they're in use. So it's much more efficient, and it's more relevant to the specific function. Now here we have unsigned int, and the reason we're not going to use int is because it's not all discrete integer values, right? The servos, they're not going to move only 1 degree or 2 degrees. They can move in any kind of continuous range in between. So that's we've got unsigned int, and then it reads the value from the Bluetooth, so it can accept all the decimal values. And then we can see these. So this data I'm storing as bits, and if I go on the serial monitor, I've printed that so you can see the values coming in through the app, basically. And yeah, we store these as integers. And then now here comes the moment where you can reattach the servos again. So here they're all detached because we don't want everything going on at the same time. And then here, I've got 4 if conditions for the 4 servo motors. And basically each of the 4 servo motors have their own unique parameters. So the values from the app between 1000 and 1180 and 2000, 3000, 4000, etc. And when the app sends in specific values that are within one of these parameters, one of these loops, the conditions are going to be satisfied. And when that happens, that specific servo motor will be reattached. And then we are going to map the parameters from the app that come in, so these values, to the degrees of the servo motor. So then it can move, basically, from 0 to 180 degrees. And that servo motor will have been reattached, so it will move. But and then the last line of the code is basically just reattach.write servo. It's just to make sure that we don't have all 4 of them going on at the same time. So this is an efficient way to redirect the current and make sure the specific servo motors are moving.